Next, I want to focus on creating ionic compounds and just the intuition that goes into knowing when you take a metal and a non-metal, what exactly is going to be formed. And so we're going to start with this question right here that asks, what is the formula for the ionic compound formed from magnesium and fluorine? And I went ahead and color-coded this periodic table so that you can see where the metals are, where the nonmetals are, even where the metalloids are. And this is really going to help you identify when a particular set of atoms is going to form a covalent or an ionic compound. And here we know that all of these particular examples are going to form ionic compounds. And the question is, what is the formula? So we know that we have magnesium and fluorine, and they're coming together to form an ionic compound. But it's not that simple because we need to account for the charges and we need to form an ionic compound with a neutral charge overall, which means the charge of magnesium has to be balanced out by the negative charge on fluorine. So how do we know what the charge of magnesium and fluorine are? Well, I'm going to give you a nice quick rule to make sure that you know exactly what the charge is. So for anything in 1A, the cation form is going to be positive 1. Anything in 2A is going to be positive 2. Now, I'm going to skip all the way to the nonmetal side now, and I'm going to go to 7A, and that is going to be 1 electron shy of the noble gas. So in order to get to that noble gas configuration, you're going to add an electron. That's going to create a -1 charge. And then for 6A, it's going to be -2. And that's going to help us with all of these problems today. So magnesium, you would find it in 2A, and so that's going to have a +2 charge. Fluorine is going to be in 7A, and we would expect that to have 1 negative charge. So if we wanted to create a balance of charge, we need to add a 2 in front of that fluorine. And that gets us MgF2, where we have a +2 charge here, and then 2 times a -1 charge here. So those are going to be totally equal to create a neutral ionic compound. So now let's do that for this entire set of atoms. So sodium and bromine. We're going to find sodium in +1. We're going to find bromine in 7A, so -1. And so that's going to get us NaBr. Calcium, we're going to find it in 2A, so that's going to be a +2. And then chlorine, we're going to find it in 7A, so that's going to be a -1. In order to get that charge balance, just like we did for magnesium fluoride, we need a CaCl2. We multiplied the chlorine by 2 in order to get 2 negative charge to balance out with the calcium. So cesium and oxygen. So cesium is way down here, but it's still in 1A, so that's going to be +1. Oxygen is over here in 6A, so that's going to be -2. Therefore, now I'm going to multiply that cesium by 2 to balance out with the oxygen. So CS2O. And that's our ionic compound. Now, this one involves polyatomic ions, but it's going to still be based on balancing out the charges. And so I have a -3 charge on this PO4 and a positive charge on the NH4. The way I'm going to balance it is I want to make sure my positive charge is equal to my negative charge. So I'm going to add 3 of these and then 1 of my PO4. That gets me ammonium phosphate. Now, iron 3 and oxygen, what this iron 3 is telling me is that this is Fe3+. And so I want my 3+ to be balanced out with my -2 of oxygen. The way I can do that is find that lowest common multiple, which is Fe. I'm going to multiply that by 2, and then I'm going to take my oxygen and multiply it by 3. And if you're curious, we would call that iron 3 oxide. So hopefully this gives you a little bit of perspective dealing with ionic compounds. But next what I want to do is show you how to look at an array of different compounds and determine if it is a covalent compound or an ionic compound. So for this set of compounds, I want to look at them and determine what type of bonds are found in each one. Remember, this is going to help us a lot with this problem. If you have a covalent bond, you have electrons shared, keyword right there, shared, between nonmetals almost all the time. And then if you have an ionic bond, that means you have electrons transferred, make that a keyword, between a metal and a non-metal. So we're going to use that to make sure that we know each of these. So let's start with F2. Very simple, a nonpolar covalent bond, and that's going to be one of our diatomics. So that's fluorine right here. That is in the nonmetal space, and so that is definitely going to be covalent. Lithium chloride, LiCl, is a compound consisting of lithium, a metal over on the left side of the periodic table, and chloride, which is an anion that is composed of the chlorine nonmetal. So that is definitely going to be an ionic compound. HCl, or hydrochloric acid, even though hydrogen is way over here on the periodic table, is definitely a nonmetal. And chlorine is also a nonmetal. And so this is actually going to be a covalent compound. Now, Fe2O3 is something that we just saw and just made that particular ionic compound formula. And that is iron, which is actually right here on the periodic table, and oxygen, which is definitely a nonmetal. So metal, nonmetal, definitely going to be ionic. So C6H12O6, that's actually a sugar, and it's going to be composed of carbon, nonmetal, hydrogen, nonmetal, and oxygen, nonmetal. All nonmetals, definitely, it's got to be covalent. Now here's a little bit of a challenge. We have sodium nitrate, NaNO3, and what this is you definitely have a metal here. And NO3 is all nonmetals, but it's actually its own ion. So the NO3 is a discrete ion, what we would call a polyatomic ion. And so this is definitely going to be an ionic compound, and because it has an ionic bond between the sodium and the NO3 minus. But that NO3 minus itself has covalent bonds in it. So it is both. It is definitely an ionic compound, but it also has covalent bonds in that nitrate ion. That's just a tricky one I decided to throw in there just for fun, but I want to make sure that you know how to identify each of those previous 5 in terms of being made of covalent bonds or ionic bonds. And that's all for this short little module, but these are really, really important topics, things that are just totally fundamental and really, really important that you know going into chemistry on day 1.